Hello, I am Atishay Jain from Group 12. This is our term project presentation of the Information Retrieval course. Our group consists of me, Gaurav, Akash, and Roopak. And the project that we have worked upon is for detecting offensive speech on various social media platforms. So, first of all, let me show you the dataset that we have used. So this is the data set and it contains three fields: unique ID, post, and label set. So we don't care about unique ID, we have post and label set. So label says like denote whether the speech is offensive or not. So if it is one, it means that it is offensive. If zero, then we not. So and this is the data or the query that we have. So as you can see, like this is a very like unformatted data. It has many blank lines, emojis, and you can see links, hashtags, tags, mentions, all those things. So first, to run any model on this, we have to first filter it. So for filtering, I'm using this function filter. So in filter, what I'm doing is that first of all, I'm removing the links which start with HTTP. Then I'm removing the mentions that start with at the rate. Then removing the emojis with this emoji module. Then remove the emojis with these codes, and then splitting the function with all these limiters. And I'm not removing the hashtags because some hashtags may be very common in hate speeches. So, like I've done this cleaning of the data, and then we have a dictionary. So this is a Hindi to English dictionary. Here we have 70,000 Hindi words which are mapped to some English word or one or more English words. Like this word angutha, like it have one, two, or some words may have four, five meanings in English. So for translation, what we are doing is that like for the query that we have got, a sentence, we are adding all the meanings of a word to the sentence. Like here we have. So if the word of Hindi is not in dictionary, then simply the word will remain as it is in the sentence. But if the word is present in the dictionary, then we will add all its meaning in the sentence. So suppose like we have this word only, which we have. So we will add thumb and ring. Sorry, these are different, but say any other thing, then we will add this murky and darkness, shade, all in the query. So that whenever a query will come with shade, it will be matched with all this. Because if we add only darkness, then if a query come in shade, then it won't be rejected as hate or it won't be rejected as non-hate. So we are doing that, and then we are just returning it. So this way we have translated our data. Then after that we have pre-processing the data that we have. So the data that we have now contains English words and the words of Hindi which are not present in our dictionary. So for pre-processing, we are using that stammer rule for stemming, quota stammer rule for stemming, and then the lemmatizing. We are using these modules to perform those functions. And after that, when we get a query, we do the query expansion also. So suppose we have a text, so to expand it, what we are doing is that for a Hindi word, we will add up to four meanings of it, but not all. Because if we add all meanings, then the weightage of that word may increase. Suppose a word has 10 meanings and the rest of the words in the sentence have only one meaning. So if we expand it, then the weightage of that word will increase very much and it will affect the its offensiveness or non-offensiveness. That's why we are adding up to four, and this will help in our increasing the accuracy. So after that, we are running the naive based model. So for the naive based model, the vocabulary size is this much, and for the naive based model, the thing that we are using to predict is this one, like not the probabilistic, but we are using the term frequency. The term frequency of a word, how many times that appeared in hate speeches, or how many times it appears in non-hate speeches. So using that, we have this function predict here. So when we got a function, we first translated it and then also query expanded it, and then all this thing we have done during the training and calculated a score. So after that, we found out that this is accuracy and these are all the results. Then we saw that the accuracy and the F1 score is not that much, so we did some modification. Now we also got some data from the internet where we have a list of bad words. So now what we will do is that if any of the word from this list occur in our query, then we will simply declare it as offensive. We won't do any naive data. So here you can see like if the word in the text, if it is present in the offensive word, then we are simply saying that it is offensive. So this way we have done some modification and our results have improved. Now to further improve the results, what modification we have done is that we are giving more weightage to the head comments. So suppose like while using this term frequency, we have calculated the probability of a text being hate or non-hate. So now we are not just simply returning whether probability 1 is greater than 0 or not. We are seeing that if probability 1 is greater than some factor of probability 0, that is probability of being hate is greater than say 0.8 times of probability of being 0. I mean non-hate, then we will say it is hate. So using this we further increase our results, and this is happening mostly because of the data set that we have. So this data set, this is like not a perfect data set, and it has some skewedness and say it is biased towards the non-net comment. So we are doing that. Now to further increase, we are increasing the weightage further. So from 0.8 we increase it to 0.85 finally, and like we increased to some more values and less value, and we saw that 0.85 is more of the best value that we have got, and it gave the F1 score of 0.6 as of now. And now like after doing this, we also implemented the classical naive base using this probabilistic approach. So after doing that, we saw that the accuracy is not that high. Like here, we have this function where we are using the class priors and all to calculate the probability, but the results are not good. So this way, we have implemented the yeah we have implemented our like offensive spell detection model. So now we have this predict function which predicts this, and I'm going to run a query on it. Say, say we have this print the predicted value of this, and this is nothing but a value from our data set. We can see this is just this second value, this one. So now if I run it, and see that it says 0, and in the data set also it is 0. But our model is not perfect, as you can see the result. So the further improvement that we can do upon this is we can use some better translation scheme. Like as of now, we are doing word to word translation. We are using a dictionary. We can do something. We can go into neural networks and translate and understand the semantics and the like emotions behind the sentence. Or we can move forward of the naive base and use some other models to train our data. So yeah, we can get into an LP and understand the sentences well. So that's how we have done it. Thank you.